If you are building AI agents to navigate complex enterprise codebases, you eventually hit the wall where standard semantic retrieval shatters. Standard vector RAG relies on naive text chunking. It breaks your data into arbitrary pieces and fetches whatever shares the highest cosine similarity with the user's prompt. This process severs the logical boundaries of the original code or documentation. This creates context rot. The AI receives a fragment of data, but loses the surrounding structure that explains how that specific function operates within the wider system. For example, an agent might request a login code to execute a task, but standard RAG retrieves a login bug ticket because of keyword overlap. The agent is left to guess its next move based on a fragment of a conversation, rather than the code itself. In domains requiring precision, like finance or medicine, probabilistic fragmentation is a liability. You cannot scale an autonomous agent that depends on statistical guesses. The industry is shifting toward graph-based memory to address this. Microsoft GraphRAG is the primary example, offering a relational upgrade to standard vectors. GraphRAG uses LLMs to map out how entities relate to each other. This enables multi-hop reasoning, allowing the AI to trace concepts across multiple, separate documents. However, that capability comes with a steep operational cost. GraphRAG requires passing massive amounts of unstructured data through an LLM to build the index. It is token-heavy and expensive to deploy at enterprise scale. Even with a graph, the traversal remains stochastic. The system still predicts the next logical step based on semantic node edges, meaning hallucinations are reduced but not mathematically eliminated. FastMemory by FastBuilder takes a different approach. It replaces vectors with a Rust engine designed to execute queries through fixed logical paths. This creates an architectural choice: stay with the familiar Python ecosystem of Microsoft GraphRAG, or migrate to FastMemory structure for repeatable, logic-driven execution. To understand the difference between semantic graphs and deterministic topologies, consider how you use a digital map. Vector RAG is a map of only roads. Agents bounce between similarity intersections, lacking rules to reach functional endpoints. FastMemory adds mathematical topology structure. Information becomes components, blocks, functions, data, access, and events, letting the AI identify requirements before interacting. FastMemory calculates the structure in milliseconds using Louvain community detection, bypassing the need for expensive LLM extraction pipelines. This architectural shift enables the agent to navigate using explicit rules of engagement rather than relying on the statistical likelihood of a keyword match. Because it skips LLM-based extraction, FastMemory reduces enterprise indexing costs by 90% compared to traditional graph extraction methods. Microsoft GraphRAG hits a performance ceiling, reaching roughly 72% accuracy on finance and legal tests due to probabilistic routing. FastMemory reaches 100% on finance bench. By isolating data into functional clusters, agents only access specifically mapped context, preventing unrelated text exposure. This node isolation ensures that the boundaries of complex documents remain intact, preventing the data degradation that often occurs during long context retrieval. There is also a speed delta. While GraphRAG's latency scales with the amount of data, FastMemory operates at a constant sub-0.5-second latency floor, regardless of dataset size. For production agents, sub-second response times and 100% precision are the technical requirements for enterprise reliability. Standard retrieval systems use external filters to block prompt injections and data leaks. GraphRAG relies on these external guardrails. If the outer perimeter is breached, the underlying knowledge graph remains exposed to the agent. FastMemory builds security into the data layer through the access node topology. Developers map identity rules, like AWS IAM, directly onto specific memory blocks. The AI agent cannot process data it isn't explicitly authorized to see. Because these pathways are enforced at the graph layer, every decision the agent makes leaves an auditable forensic record. For regulated environments, compliance must be part of the foundational floor plan of the AI's memory, rather than an external addition. Choosing between these systems depends on your scale and your tolerance for hallucinations. Microsoft GraphRAG is effective for exploratory tools and general knowledge synthesis, particularly for teams that want to remain in a Python-centric environment. FastMemory is built for autonomous systems in sectors like financial trading or legal auditing, where a single false positive has significant consequences. There is also a licensing threshold to consider. Small teams and startups can use FastMemory under an open source license. However, organizations generating over $20 million in annual revenue require an enterprise license. Your choice should align with your project's legal risk, indexing budget, and latency requirements. Microsoft GraphRAG is a significant improvement over standard vectors for relational research. The FastMemory Sovereign Suite provides the verified audit trails and logic mapping required for high-stakes enterprise agents. Evaluate your current RAG stack's failure rates to determine if your application requires a topological upgrade. The reliability of an AI agent depends on the mathematical structure governing its navigation of data, not simply the volume of information retrieved.